Hello everyone. So I'm going to be taking a look at the back side of the exponent sheet that we started with, operations with polynomials. So last week we worked on all of the multiplication properties on the first side. Now I would like to take a look at the back side of the paper and just explore these properties of division first and then some of the others afterward. So if you think about what we have here on the top, a divided by b, quantity raised to the fourth power, that is like saying a over b times a over b times a over b times a over b. We have 4 of the a's and 4 of the b's, and so we have a to the fourth divided by b to the fourth. So in this case, we are raising a quotient to a power. So when we do that, we are going to keep the base, which is our a over b, and raise each to the fourth power. So this is like 1 times 4 and 1 times 4. So we multiply the exponents inside the parentheses by the exponents on the outside. As an example, when we have x cubed divided by y to the fourth power, everything squared, we're going to raise a power to the quotient to a power by multiplying the 3 by the 2 to get 6 and the 4 by the 2 to get 8. So we end up with x to the 6th power over y to the 8th power. So this works the same way as raising a power to a power that we did last week. The difference is that we have a quotient at this point. So if we look at the meaning of a to the 6th power divided by a to the 4th power, the long way would be to write the product of 6 of the a's and 4 of the a's. So we have 6 of the a times a times a times a times a times a divided by a times a times a times a. Notice that 4 of them cancel out because a divided by a is just 1, and we're really just left with 2 on the top. So we're left with a squared. As a shortcut, when we divide like bases, we keep the base and subtract the exponent. So it's just the opposite of multiplying like bases. When we multiply like bases, we keep the base and add the exponents. When we divide like bases, we keep the base and subtract the exponents. So we end up with a to the 6th power divided by a to the 4th power is a squared because 6 minus 4 is 2. So some examples: x to the 15th divided by x to the 12th. 15 minus 12 is 3. So we keep the base, subtract the exponents. Over here, we have the same base, so we keep the base, subtract. 5 minus 3 is 2, so 2 squared is our answer, which ends up simplifying to be 4. So a nice little rule that we have is this one here on number 6. When we divide any number or term by itself, it cancels out and you get 1. Just like 2 divided by 2 is 1, 5 divided by 5 is 1, a to the 4th divided by a to the 4th is 1. We have 4 of the a's on top, 4 of the a's on the bottom. As a product, we cancel, and we end up with 1. But if we think about the rule that we saw up here, when we divide like bases, we keep the base and subtract the exponents. When we subtract 4 minus 4, we get 0. So really what we have here in a sense is a to the power of 0 because 4 minus 4 is 0, and we know that this has to equal 1 because any number divided by itself is 1. So as a nice little rule here, any number that is not 0 raised to the power of 0 is equal to 1. So 2 to the power of 0 is 1. 10 to the power of 0 is equal to 1. 100 to the power of 0 is equal to 1. 5 million to the power of 0 is equal to the 1. 2x squared raised to the power of 0 is 1. Negative 3xy to the 5th power z squared to the power of 0 is equal to 1. So I hope you get the hint of that there, that when you have a non-zero number raised to the power of 0, it is equal to 1. So last rule. This is again a division rule. Okay, but it's a little bit different. Notice how this time around the exponent is larger on the bottom than it is for the top. So when I subtract these exponents, 4 minus 6 gives me a negative 2. Now in math, it's just not really proper to leave exponents written as a negative, so we usually change them to be written as a positive. But let's look at what happens if we expand it out. So if we expand it out, we have a times a times a times a divided by a times a times a times a times a times a. 4 of them are going to cancel, and we're left with 2 of the a's on the denominator, or 1 over a squared. So let's compare these. Over here I have a to the negative second, and over here I have 1 divided by a squared. These two things are equivalent. So when we have a negative exponent, we deal with that by taking the reciprocal of the base, and we change the negative sign to a positive exponent. So for example, x to the negative third power is the same as 1 divided by x cubed. 2 to the negative fourth power is the same as saying 1 divided by 2 to the fourth, or 1 over 16. We don't get a negative number, we just get a small number. So that's it for now. Thanks, guys.